Hello and welcome back. I will be using Python via the Jupyter Notebook, which is an open source web application that allows you to create and share documents that contains live code, equations, visualizations, and narrative text. I will tell you more about Jupyter in the next course, and I will help you install it in your machine so you can use it to run the demos, practice, and do some exercises. For now, I would like you to observe and see how easy we can apply and complete our task. First, I will be importing decision tree method from a machine learning library that we will be using quite often. This library called scikit. It also contains many other classifications, regression, clustering algorithms, and many other tools. Next, we will tell Python to read the data from a CSV file that I showed you earlier. And just to make sure, here we can see the first 5 records of the file and everything looks as expected. So I did not have to tell Python how to read the CSV file. I do not have to write the decision tree algorithm from scratch. It's all made for you. You're just gonna bring it and you can use it. Then again, we will use scikit to import another method that we will use to split the data into training set and testing set. The only thing you need to do is to choose what percentage you want to put for training and what percentage you want to put for testing. We will choose 60% for training and 40% for testing. Then we will call the decision tree method, and that's it, it's done. That's about it. The classification model is built using the training set. Now we can use the testing set to see how good is our model. For instance, we can check the accuracy of the model by calling accuracy decision.score test x test y, which tell us it is 95%. Whether this is good or not, it depends on many factors. How well was your previous model? If it was 97, then this model is not as good. If it was 90 and now you have 95, okay, that's better. And also, how critical is your application? Is 95% enough? Do we need to have 99%? The room for error must be very, very small, or there is a room for error. So it depends on the application itself, and so on. Since we use the decision tree model, it will be nice to show a visual representation of it, right? Can we do that? Yes, we can. We have, as you guessed by now, the libraries and packages that could do this for us. And now we can display the model visually, as you can see here. And we can even control how it looks, colors, the information within the tree, and any other settings you want, which you can read in the documentation of the package. So if you have a new instance or an example, in other words, an iris plant, and you would like to know to which class it belongs, you can trace the tree model and know which class it belongs to, according to this model. We did all of this in less than 20 lines of code. Of course, I did not explain in details what each line of code does in this course. We will definitely go through the implementation in much details if you decide to dive in deeper into the field. I just wanted to show you how quick we can complete a task if we know the steps and we know the libraries that we need and everything is available for us. That's it. I hope you enjoyed the course and you found it useful and informative. And I hope I helped you decide whether or not you would like to work in this area and to learn more about it. If so, check the next course, which covers machine learning topics and methods in much more details. And it goes a step-by-step format, followed by hands-on training for each topic covered. Thank you again for enrolling in this course, and have fun with machine learning.